destroying the countryside for centuries. Did you realize that nuclear radiation has been part of the human experience since the beginning of time? People were oblivious to nuclear radiation because their senses couldn't detect it. If somehow they could have changed the sensitivity of their eyes, they would have realized that it was emitted from certain types of rocks, and to some extent from all living things, including themselves. It was the mid-19th century before a series of events occurred which revealed to man the existence of radiation. Michael Faraday experimented with a glass tube enclosing electrodes and connected to a source of high voltage. When air was pumped out of the tube, streamers of light appeared between the two electrodes. Other scientists found that as more and more air was pumped out of the tube, the pattern changed. When such a highly evacuated tube has a fluorescent screen placed in it, the appearance of a glowing line on the screen suggests that something is moving between the cathode and the anode. Cathode rays was the name eventually given to these mysterious somethings. Other experiments showed that electric fields would deflect cathode rays. The experiments also revealed that a magnetic field would also deflect the rays. These observations suggested that cathode rays were negatively charged particles. When Wilhelm Röntgen began to study these cathode rays, he made a startling discovery. He was experimenting with a cathode ray tube, which was highly evacuated and covered with opaque paper. By chance, he had some chemically treated paper near the apparatus. When the cathode ray tube was turned on, the paper began to glow. But it stopped the instant the tube was turned off. Röntgen concluded that mysterious rays were being emitted by the cathode ray tube. He called them X-rays. The medical profession was quick to make use of these rays. They could penetrate opaque material, such as black paper or living flesh. X-rays could also expose photographic plates, which could then be developed to produce an image. X-rays were not like cathode rays. An electric field would not deflect them, nor would a magnetic field, which suggested X-rays were not charged particles. In spite of their different natures, X-rays and cathode rays have something in common. Neither are forms of that still unexplained mystery, nuclear radiation. It was Henri Becquerel who, while exposing X-rays, would discover nuclear radiation. Some substances, when placed in sunlight, are fluorescent. They emit visible light. Perhaps they also emit X-rays, proposed Becquerel. To test his hypothesis, Becquerel used photographic plates covered with opaque paper to prevent them from being exposed to sunlight. On the paper, he placed a fluorescent chemical compound. When the photographic plate was developed, it should show no exposure from sunlight because of the opaque paper. So any exposure of the plate should be proof that X-rays had penetrated the paper. For a whole month, Becquerel was unable to find a fluorescent chemical that would expose the photographic plate. Then he tried potassium uranyl sulfate. This time, after following his regular procedure, Becquerel found that the photographic plate was slightly exposed. Was the radiation actually coming from the potassium uranyl sulfate, or was it coming from somewhere else? He placed an object between the sample and the photographic plate. When the photographic plate was developed, the shape of the object appeared, which seemed to verify Becquerel's hypothesis that X-rays were being produced directly from his fluorescent sample. But one morning the sky became overcast, shortly after he prepared another potassium uranyl sulfate experiment. So Becquerel put the experiment away. When the skies remained overcast for several days, an impatient Becquerel decided to develop the plates anyway. To his great surprise, the plates were strongly exposed. He soon realized that the sample had given off some type of radiation without being stimulated to do so by the sunlight. These Becquerel rays were similar to X-rays in their ability to penetrate paper, which was opaque to visible light. They seemed, however, to differ from X-rays, because X-rays could be turned on and off, but not Becquerel rays. Later, Becquerel found that in the potassium uranyl sulfate, it was the metal uranium that seemed to be the source of Becquerel rays. The Becquerel rays were not affected by the addition of heat or by treating the uranium compound with chemicals. Becquerel also tested his rays with an electroscope. When an electroscope is charged, each leaf has an excess of the same electrical charge. The leaves repel each other. Normally, air insulates these leaves and they discharge only slowly. But Becquerel radiation seemed to change the nature of the air around the electroscope. The air became a conductor, and excess charges from the electroscope leaves were quickly neutralized, thereby discharging the electroscope. What exactly was the source of this radiation? Marie Curie found that the element thorium also emitted these rays. Along with her husband, Pierre, Marie started with a huge pile of pitchblende ore and developed a laborious process to extract very small amounts of two new elements which were powerful emitters of Becquerel rays. They named these elements polonium and radium. Unlike a cathode ray tube or an X-ray tube, where electricity provides the energy to produce the radiation, these Becquerel rays seem to be emitted without any outside source to provide the energy. It was Marie Curie who coined the word radioactivity to describe the process whereby substances spontaneously produce radiation. Others were soon to join Becquerel in the Curies. They would explore and discover the source of this radioactivity, the nucleus of the atom.